Hey everybody, so today we're working on the electrolysis experiment. This is it. So this experiment involves looking at the process of electrolysis, which is splitting water molecules to produce oxygen and hydrogen gas. It's essentially a way to store energy in a fuel, hydrogen being a fuel. So the productive part of that is really creating hydrogen as a fuel. So we're putting some energy in to split those molecules, and in doing that we're storing energy essentially in the hydrogen as a fuel. The process takes place in what we call electrolysis cells, and we have two different types of cells that we're going to look at in this lab. The first type is an open cell. So here it's open to atmosphere. So there's you can see the actual cell here is here. There are two electrodes in there. We apply a voltage across that and let current flow through, and in doing that there's water solution in the cell, and it produces hydrogen and oxygen, which then rise up to the top. Right now it's vented to the atmosphere, to room, so the gas would just flow at the top. On the other side is also vented. So during the experiment, what we'll do is close this top valve. That'll seal up this part of the cell. And as the gas is produced, it'll rise up in here, pushing that liquid level down. And by measuring the change in that liquid level, we can figure out how much total gas was produced during the experiment. So we'll get started with that right now. So if I look at this particular cell here, I can see how the setup is connected. I have a power supply down at the bottom here. I have an ammeter here. So my power supply is connected. I'm going from the output of the power supply to one of the electrodes in the cells. Coming out the other side of the other electrode, I'm going through my ammeter, so I'm going to measure the current in that, and then back to the return on my voltage supply. So that's a complete loop where you just have basically the cell in the circuit and the ammeter in the circuit measuring the current. So if I know the voltage, I know the current, I can calculate the power I put in to generate a volume of gas. So I have three different versions of this cell. And what we're going to do is look at some of the factors that affect the efficiency of the process. So you note there are two electrodes here, as we said. In all the cells, they're made from the same material, but there are slight differences between the cells. So two of the cells have different spacing between the electrodes. So we'll look at the efficiency, we'll compare those two and see how that affects the efficiency of the gas production. The other two have the same spacing, but they're going to have a different concentration or a different molarity of the solution that's in the cell. So there's a potassium hydroxide solution that helps speed up the process. The chemical we put into these cells to produce the ions are, so you have a solution of water plus we're using this potassium hydroxide. What this does is it dissociates in water and puts in potassium and hydroxide ions into the solution. It makes it a much better conductor of electricity. So you could, if you take water, just tap water, and you put it into one of these cells, you'll see that as you turn the voltage up, you can actually get electrolysis happening there. That's probably due to any impurities in the water. There may be some ions that are in there. If you take very pure water, we call millicube water, it's filtered out where they get all the ions out of it, then the water is actually a decent insulator if it's really pure and you don't have any ions in it. But you can sort of measure, you could actually measure the conductivity of this or its efficiency in this process by looking at, again, at that turn on voltage. So for a given spacing of the electrodes, how much voltage does it take to start that process? And then once it gets going, you can also see differences in the rate of gas production in the cells as well. With these cells, it's worth mentioning that the efficiency can also be affected by the rate here. So if you're producing gas at a very fast rate, you're accumulating bubbles on the cell, on the electrodes. So I'll turn that on and actually show you. So you see, as that gas is produced, it's sort of coating the surface of the electrodes, and that's going to have an effect on the conductivity, right? If you have actually a layer, what you want, ideally you have the best conductivity when you have that solution right up against the electrode. If you have a layer of bubbles there, then you're reducing the amount of surface that's actively working to transfer charge, and that's going to lower your efficiency. So there is a rate factor there. You might think, well, why don't we just if we turn up the voltage, we can get it going really fast. But then you have this efficiency issue where you're coating the surface essentially. So in a real commercial system or something where you're trying to optimize it, the efficiency, you might want to set up some kind of a flow through here that moves those bubbles off the surface as quickly as possible. So for the first step, what I'm going to do is try to find the turn on voltage. So as I turn up the voltage, at some point you'll start to see bubbles coming off the electrode. So we want to very slowly bring up or increase that voltage and see if we can find the voltage at which that process begins. That gives us some indication of the concentration of ions in the solution, so how easy it is to start the process. It will also be affected by the spacing. If you think of this as a big resistor, and you're trying to apply a voltage across that, at some point your current slowly increases, or in this case maybe once you reach a certain potential, it almost comes on a little more like a switch. So once we've recorded that, we call the turn on voltage, we're going to shut down the system, maybe disconnect that, turn the voltage down. Now we're ready to run. So what we want to do here is close this ball valve from the top. So before it was open, so any gas we were producing was just venting out. Now we want to actually accumulate that gas and measure the change in volume. So we're going to close that off, and then we're going to take a piece of tape and mark off the level here of the liquid in the tube. So right there. I can do the same thing on this side just as a backup. I think it's actually a little easier to read on this side. So I'll mark off the level here and here. And then what we're going to do is start the process, and then periodically, so every 30 seconds or so, we'll take a reading of the voltage and the current and track that over about a 10-minute period. Right. So if I know where my voltage is, turn on voltage is, I'm going to set my voltage for 2.2 volts. It's a little above where that is. I'm going to start my timer, and then I'm going to start the process. So I see the gas starting to be produced. I have a current flowing and a voltage, and I'm just going to track those over about Okay, so then after 10 minutes, what you're going to do is just disconnect one side of the electrode. That'll stop the process. And then what we're going to do is, so we want to measure the change in the volume of the gas. So remember, as the liquid started up here, as we accumulated gas up top, it pushes the liquid level down to there. And then on the other side, it pushes the liquid up. So this distance should be the same as this distance. And what we can do, just take a micrometer, and we can measure that. So you can measure from the bottom line there to the top of the tape, and the same thing here. One small thing to consider, it's not a big difference here because it's only about an inch or so change. But if you think about it, what's happening now is you have some amount of gas accumulated in here. And the level of these liquids is offset a little bit. So this one is down a little bit lower than this one here. So what could be happening is the weight of this column of liquid is actually pushing down on here and compressing the volume of that gas a little bit. So to correct for that, to compensate for that, what we can do is just move this whole level here. I can move this whole thing up or down, or I guess this one, maybe it's easier to move this one out, so that they're both at about the same height. You can measure that, but then, so that means there's no differential pressure compressing that gas. And then once you do that, then we can take a more careful measurement of the height of the liquid there, height of that. You could take an average of the two, and that's going to be the volume of gas produced. Now remember, that's the volume of oxygen and hydrogen combined, right? So we need to figure out a way to separate out the hydrogen. We want to know the volume of hydrogen produced. So after you finish that, you're going to go through and repeat that same procedure for each of these three setups here. So for each one, make a note of what actually there's a number on the stand that for each one is number 3, 4, and 5. Just make a note of, you can even measure with the caliper, the spacing of the electrodes, anything you observe about the configuration of them. In particular, if the two of them have the same spacing, one of them, you can see this one's a little foggy, but these are spaced a lot closer. It should be about half the distance. So just make notes about what you observe about each one. Remember, for each one, before you start, find that turn on voltage where the process begins. Be sure to close the ball valve on the top, otherwise you won't see any change in the level, and make sure you mark your initial levels carefully. One other quick note is you also want to make sure, as you accumulate gas, it's going to push this level down. So you want to make sure when you initially start that you're starting with the level up somewhere in the middle or towards the top, so that when it goes down, you can still measure the change. Okay. Some other factors that can affect the efficiency there are the quality of the surface on those electrodes, the metal that they're made of, whether or not you have any kind of oxidation or build up on the surface that can affect it.